about this, and I pulled together a number of utility executives recently at the chamber, to talk about this. And I want to give a shout out to Judd Turner, our director of EPD. Judd is he's a University of Georgia grad like me, so of course he's a very smart guy and a great guy. But Judd is quarterbacking our compliance, and I saw him at the election night festivities. Of course, he's an appointee of Governor Deal, and we were talking about pine trees. I said, Judd, man, they're not giving us credit for any of our pine trees that absorb all the CO2. Let me just vent about CO2 just a quick second. I was helping this company, wanted to come to Georgia. They grow these little English cucumbers in the hydroponic. Yeah. So they grow these cucumbers. I was looking for a great location for them, and they said, what we need flat ground, we need access to water, we need natural gas, and we need CO2. So I said, well, what about down by the ethanol plant in Camilla? Because one of the byproducts of ethanol production is CO2. And so I brokered the arrangement for them to get with the Camilla folks, and they're going to put the greenhouse next to the ethanol plant because you know what they pump into a 40-acre commercial greenhouse? CO2. And here's my vent. I'm a big fan of nuclear power and reprocessing spent nuclear fuel. I was over in France a couple weeks ago with Areva up at their La Hague facility, and I've got an op-ed circulating around the country right now about the Mox site over at Savannah River site and why we need to finish it. U.S. News and World Report took a whack at me yesterday about this, and I don't know where they got that photo of me, but anyway, they took a whack at me. But you know what bothers me is that we've got all this nuclear spent fuel that's radioactive for 1 million years, and it's on page 13, right? Anytime you see anything about it. CO2's up there on page 3, maybe page 2, sometimes below the fold on page 1. And we treat CO2 like it's worse than spent fuel. And we have made CO2 such an enemy, and we've failed to really do the right thing with our spent fuel, right? I mean, it's all sitting on my plant sites here in Georgia, and our ratepayers have paid $1.3 billion for the federal government to pick it up. So my venting is that, look, I tell my environmental friends, look, let's take care of this spent fuel and nuclear waste, and then you come talk to me about CO2. Let's have the government keep their promise on the waste before they come up with yet another rule that's going to adversely affect states like Georgia, and our CO2 number, 47%. Imagine men, especially here, someone told you had to lose 47% of your body weight. You'd attack them. So this rule, I hate to say this rule is a backdoor effort to bring about an RPS on states like Georgia that doesn't have a renewable portfolio standard. You know what? We're the fastest growing solar state in the U.S., and we don't have an RPS. And I think that ticks off a lot of people in Washington, D.C. We're the #1 market for the Nissan Leaf in the U.S. I think that ticks off a lot of people in Washington, D.C. That, hey, Georgia, every constitutional officer in our state's Republican, every one of them, all the way down. Governor all the way down to the lowly Public Service Commission where I serve. And we are leading the nation in so many of these categories. And, rules like 111D wind up just being a wealth transfer. It's transferring our wealth to some other state. So, you getting the idea how I feel about this rule? All right, let's talk about the Kansas City Chiefs or something. My blood pressure can go down. So, Anyway, Dennis, thank you for being here, and I look forward to your perspective on this.
Well, how do I follow that? I got to drive here on election day, and that was a good thing because I got to vote early, but I didn't get to vote often. And I got to be here for the celebration of the senator, which was kind of a nice thing. It's not something that you do every day. So, and I'm kind of attached to Georgia. I was an expert witness in a permit hearing for the power plant, I believe that my friend here just mentioned, and got to spend a week sitting around a hotel and walking around downtown Atlanta waiting for my turn. And it was an interesting process. Then I got up there and did what I was supposed to do. And the lawyer for the Sierra Club kept saying, "Judge, he's not answering the questions." And I just said to the judge, "He's not asking the right questions." So I prepared this slide last Friday, and I realized it was Halloween, and I was scared. It was the first Halloween I didn't even have trick-or-treaters come to my house because I grew up with coal, and I like coal, and one day I want to retire, but I don't want to retire as a dinosaur. Think about that. That's humor. But and if you look at the rules that we're dealing with, and I begin to wonder what's the EPA rule writers going to do in 3 years, because there's nothing left. And I didn't put regional haze on here because it's kind of scary to put that on. But if you look at what we're faced with as an industry on everything, these are permitted plants. They're plants that have been running. They're making electricity. They're making a reliable electricity, but yet they're not good enough. And it is kind of scary. And I just thought, not everybody goes to a power plant. And this is actually a picture of the Oak Grove station. And over to the right are the boilers. It's kind of interesting plants. Each of these are about 880 megawatts. And the rest of the stuff is all air quality control systems. And I'll get back to this slide a little bit later. A little bit on Fluor. Kind of obligated to talk about our company is the power business is one of 5 major units of Fluor. We work on power plants all over the world, primarily U.S., but I've been doing a lot of work in Saudi Arabia, of all places, building oil-fired process boilers for aluminum smelting. And actually had the honor of putting the first FGD, SCR, and precipitator on an oil-fired unit in the Kingdom of Saudi Arabia at the Saudi Cayenne project. We do solar, wind. We have nuclear processes, including ownership in NuScale, which has a little bit of traction and something we're kind of very involved with. And if you look at a snapshot of what we've done in the United States, it's quite extensive. As a EPC supplier, we do construction engineering, and we've done it on a number of technologies for power, for environmental, over the last several years. So this is a 20-year snapshot, actually. A lot of gas combined cycle, a lot of environmental projects that fit the regulatory needs of the country. One thing I wanted to point out is CSAPR has come and gone and come. CARE has come and gone, and I think it's gone, but I'm not really sure. And I do care, but a lot of the stuff, a lot of the control things that are necessary have already been done. The big plants, none of the projects that we worked on got stopped when CARE was stopped. And they were put in because of CARE, because what followed up was mats. And if you're already doing a scrubber, you're going to meet mats for most plants. So a lot of this stuff has already been done, except for a big class of units that are smaller that just really haven't had the controls. And what's going to happen with those plants, considering the nightmare of regulations that's impacting these plants that are right now sitting operating correctly on their permit. One thing I want to mention relative to MATS is SO2 and HCl controls. You know, MATS was the first law that went to HCl as a pollutant. And the solution, which is a correct solution, is dry sorbent injection. There's been a lot of work done in that area, but it's not necessarily the best solution if you're going to run your plant for a long period of time, especially if you're trying to capture SO2 just because of the cost of those reagents. So those are part of the mix, and as I was involved with permit discussions, I am also very grateful that I'm not the person that has to make the decisions on what to do with my 30 or 40-year-old power plant, that I'd really like to just sit and run and make electricity and serve my clients. Also, a number of our clients and your peers in the power production have proceeded to do work in the areas where regulations are coming forward, because the regulation is going to get here maybe next year, maybe 5 years from now, maybe 10 years from now, when everything sorts through the courts, which is really not the place where our regulations ought to be made. It ought to be made by scientists and not lawyers and judges. But it is what it is, and we've done a number of cooling tower projects, bottom ash conversions. Those things are happening today, and a lot of utilities are saying this asset it makes sense. It makes sense for me from a liability issue. It makes sense for me from pending regulation. And these type of projects are being done, and certainly is work that Fluor has been involved with. Now, we've all heard enough about the other regulations, and I thought I'd focus on a little bit different part of the clean power plant, and that is, what if you really were going to put a CO2 capture system on your existing coal-fired power plant? What would you do? And I was pretty sure that not many other people in the speakers would talk about this, so I wanted to make sure I had something new and interesting to talk to you about. And Fluor has the technology to do that, which, interesting enough, we purchased from Dow in 1989 and have worked in a continuous improvement, building over 30 CO2 capture systems that remove carbon dioxide from a combustion source. Most of those are diesel engines. In fact, we've been continuously doing this in Europe for Coca-Cola. And it's always nice to me to know that when you're in Europe and you buy a Coke, the CO2 comes from a Fluor CO2 process. We've also done a lot of work on studies in the coal industry, because even up to now, there's nothing that requires this to happen, but our clients want to know what's it going to cost and what's involved, and we've done 60 megawatt units for NRG, 240 megawatt unit, which is actually being built by someone else, interesting enough. We've won a project in the Netherlands called Road at 240 megawatts. However, they signed Kyoto and didn't do what Kyoto said they were going to do, and they haven't built it because these are fairly expensive processes. We also were selected at Tenaska Trailblazer, a plant that was permitted with CO2 capture in Texas, and basically wasn't built because the Waxman-Markey law, which would have done cap and trade, created a value for CO2, which would have helped this project go ahead. And without that value for CO2, the performer just didn't work. But this is a project that was permitted. I'm actually going to show you what that looks like at that scale. In addition, we've done a lot of studies for industry and gas-fired power plants, which at 1,000 megawatts. So that's very large plants. And interesting enough, capturing CO2 from coal is easier and less costly than capturing it from natural gas because of the amount of moisture in the natural gas and the gas volume relative to the amount of CO2 that's present. We have been running a pilot plant in Germany for the last 2 years, actually over 2 years. It has all of the modern features of economy and FG+. We've been doing a lot of work with optimization, power optimization, mainly because of the parasitic load. There's a picture of this in the foreground. Wet FGD system is to the right. It's about a 5 megawatt pilot, co-funded by E.ON out of Germany with Fluor, and really is the source of information on coal-fired flue gas. All the other processes that we've done are flue gases not from coal. And it gives us the confidence to design and operate CO2 capture systems if and when they're required on coal, if and when the finances in countries like Australia, Norway, the Netherlands actually comes forward and they do move forward with these projects of this scale. So why is that important? Well, we have 2 clean power regulations pending, well, more than that. But we have the new source performance standards, which it is what it is, going through the systems, and interesting enough, it drills down to a 1,100 pound of CO2 per megawatt hour for a new power plant that would be a coal-fired power plant built in the United States. And I'll talk about that number a little bit later. We also have, of course, we've heard a lot about this, so I won't spend a lot of time on it, but the existing sources is in the comment period, and kind of interesting because the CO2 is allocated per state, and in some states the requirement for CO2 is less than the proposed requirement for new units because of the way the allocations are and how that's being done. And that, to me, is kind of an interesting dynamic. So, what does an 860 megawatt CO2 capture system look like? I don't know, we don't have really a pointer, but all of the stuff that's kind of in green in the background is the coal-fired power plant. Includes fabric filters, SCR, that little green tower, well, it's not so little, but it has a blue thing coming up to it on the other side of the blue chimney. That's the wet FGD system. So everything in the foreground is CO2 capture system, and this is actually the 3D model of the Tenaska Trailblazer CO2 capture system, and it's shown as an air-cooled system because even though the plant was going to be located in Sweetwater, Texas, they should have called it No Water, Texas. Air-cooled is the most expensive option, but it certainly avoids some of the other water-type regulations that are pending. And what you see is on each side of the stack is the CO2 absorber, and a little bit farther out from the stack is the direct contact cooler. You have a building for CO2 compression, and you have the CO2 regeneration systems, actually 2 systems. 2 trains were required for a plant this size. And this is a unit that Fluor designed and was actually paid for by Tenaska, who was paid for, the study was paid for by the Global Carbon Capture Institute out of Australia, interesting enough. And we've did a very detailed design and pricing and also made guarantees if this project would have been built in terms of performance and CO2 capture. So back to why these things cost that much. I wanted to show you the same drawing of Oak Grove, and if you look way down at the bottom, there's a pickup truck. So I want to get you a perspective of what's being built and what the magnitude of this is. And let's take that even one step further. You see the wet FGD system, which was the little green thing on the other side of the stack in the last picture. And if I blow that up and I'm looking at the other side during construction, you can see right there where this purple arrow is pointing, there's 2 men standing there. So these are not insignificant projects, they're not insignificant plants, and that's the 2 guys that are just working on that wet FGD system. So hope you get a feel for what is involved with CO2 capture from a coal-fired power plant. So that is where the FGD arrow is pointing, and those men are staying there. You can see we could put all of the NFL football team along that absorber tower. It's over 200 foot tall, and there's 2 of them required to do that. So I thought you might find that interesting. So the science is uncertain. 1,100 pounds per megawatt hour, where did it come from? I actually researched, and the best I can tell, it came from a California rule in 2006, and they basically said we're doing natural gas, and so that's the limit. We can debate what's happening with the climate, how man is impacting or not impacting, but that's really not the point of this. But I wanted to tell you it's expensive. This is CSAPR Boundary Dam, and it's a 100 megawatt unit, 100 megawatt net. So they're producing 100 megawatt power, and they spent, right out of the publications, $1.4 billion. Now it's not real money because it's Canadian dollars. But if you look at the EPA said it was going to cost $7.7 billion. If they could take this to 10%, take it down to 1.4 billion for 1,000 megawatts, it's still well over, the potential cost of CO2 capture is well over $7.7 billion. I can guarantee that. And I'm assuming the 1.4 billion did include the wet FGD, did include turbo modifications, and they also had a pipeline they had to run. So I'm not sure what's all in there. And I know I bid on the project, didn't win it. It was CanSolve, a Canadian company, even though Fluor is also a Canadian company. But anyway, that's the point, is these things are expensive. I'd love to build them because that's what I do. I also want to point out that the announced retirements, 72 gigawatts, if the industry decided to replace them, it's going to cost more than $7 billion, believe me. 72 gigawatts of natural gas combined cycle, you're looking at hundreds of millions of dollars. If you, and the permitting process and everything that's involved. And what's going to happen to the poor 44.7 million people who don't have power because these things are shut down in the year 2016 or 2014? Something to think about. So I wanted to just give you one more example of some options if you had to do CO2, and I just picked a 500 megawatt plant. So if you're going to do it and you had to get to 1,100 pounds per megawatt hour, maybe that's a 60% reduction, more or less, depends on your cycle efficiency. So you could reduce your power output by 15% to 425 megawatts, or you could increase the plant generation, and guess what happens then? You've got to remove 100% of the increased generation. So if you're going to build another coal unit to supply the parasitic power, it's got to be 600 megawatts, not 575, because you got to remove 100%. So now you got to capture 67%, not 60%, and it gets complicated. If you add natural gas capacity to do that, it's a little bit less costly, but the natural gas volume is higher, and the capture cost is therefore also higher because the vessels and the absorber tower is larger. You could convert to a different fuel. Very difficult to do. You'd end up derating your unit for most fuels, natural gas or biomass, or you could retire and replace that facility. So those are options, and where's the good option? I don't find it. But if you do get to a decision of building a CO2 capture system, I recommend that you make sure you make it large enough, because you won't want to run that during that peak period of time, and you've got to make sure you have the 3-year averaging time that the EPA has said would be done, because if your end user can't take it, you shut it down. There's no way that CO2 is leaving your power plant except in a pipeline as a supercritical fluid. It would take a tank truck every minute for a 500 megawatt, and actually maybe 2 a minute. So it's just an overwhelming amount of CO2. So I know I'm getting close on time. I was going to wrap up like what makes sense. Well, what makes sense is diversification of the power production. We need coal because you can store it on your plant, and it's a good base loaded fuel, and it's part of what's made the U.S. the power that it is. Low cost available coal. We need reliability, and we need affordability. If you ask anybody that's buying electricity, do you want clean water? They'd say yes. Do you want clean air? They'd say, oh yes, definitely. Do you want to pay twice as much for your electricity in order to get it? No way. So what's the balance? The decisions I know are very complicated because of gas, and I also want to point out is a global issue, and we saw that yesterday in the AEP presentation. So I've asked a number of utilities, what do you think about clean power plan? And mostly I get shrugging because we don't really know what's going to happen. We're in the comment period. There's 1.5 million comments, and I bet you it goes over 2 million by December. But it's such a complicated process. And I'm ready to build CO2 capture plants for you, and we'll entertain any questions.
Get out of my state. No, just teasing. A truck every minute, a tank truck every minute in order to get that CO2 out of there. Where are you going to take it? Where are you going to take it in the tank truck? Going to take it to a saline aquifer somewhere? Or, I mean, I know that's not your problem, but.
You know, one of those tank trucks could be used for food grade, and you could take it to all the beverage places, but I don't know what you do with the other 3,000 or 4,000 a day.
I guess.
But saline aquifer is a solution, and certainly there's a lot of work being done to prove that works. But in my opinion, as much as I'd love to build CO2 capture plants and I'd love to do this, as a society, we shouldn't do it unless it's enhanced oil recovery. And that's the only place that makes practical sense to use CO2 at the volumes that would be produced by a power plant. Putting it in the ground and hoping it stays there for 1 million years doesn't make sense to me.
It's not sustainable, is it?
Well, within 1 million year, with the right conditions and time and pressure, it could become diamond.
Okay, I haven't thought about it like that. Yeah. Any questions about CO2 capture? We do have a question. We are going to take our break right after this. You can be filling out your forms, this speaker, too, while we get the question. Go ahead, sir.
This is more of a comment, but on the Boundary Dam, the $1.4 billion cost that's being bandied around, we kind of choked on that because it's only a 160 megawatt unit. Now, if that was 1,000 megawatt or 800, that might be more understandable, but when you probe into that, you find out that the cost of the CCS system was $750 million, and $650 million represented refurbishments of Unit 3, that it's questionable whether you want to assign things like overhauling a steam turbine to the cost of the CCS system. And again, I would say that, you know, if the climate scientists are telling us that we need to control emissions, CO2 emissions, to the level of 80 or 90%, how else would you do that? You could go nuclear, not cheap. You could go renewables. Again, much more, you know, both of those options are arguably more expensive than coal with CCS. The cheapest option is natural gas, and I don't work in the power industry, but if I did, I'd be real nervous about committing more than 75% of my assets to natural gas. Yeah, it's great. I'd go up to 70, 75%, and I'd max it out as what I could. But if you put, you know, if we put all of the eggs in the natural gas basket and increase that demand by 20-25%, we all know what the result is going to be. So sorry, it's not really a question.
No, well said. Any other questions? All right, great. We're going to take our networking break. You'll hear the bell.